Hi guys, I'm Engineer Aguilar, and in this video, I will show you how to determine if a function is odd, even, or neither in just under 5 seconds. So stick until the end of the video if you want to learn how to do so. So algebraically, we can define an even function when f of x is equal to f of negative x. So simply what that means is that the graph of the function is symmetric about the y-axis. Using y is equal to x squared as our example. So let's evaluate this function. So we have y is equal to x squared, or just f of x is equal to x squared. Next, we have to find f of negative x. So what we have to do, we just replace x with negative x, giving us negative x squared. So this can be rewritten as negative x times negative x, and negative times negative is equal to negative. Therefore, we still end up with x squared. So f of negative x is equal to x squared. So f of negative x is equal to x squared, and f of x is equal to x squared as well. Therefore, we can say that y is equal to x squared is an even function. Sir, paano pag may constant? When we have a constant, for example, y is equal to x squared plus 1, or f of x is equal to x squared plus 1, then we just apply the same thing that we did earlier. So we just replace all x with negative x. So f of negative x is equal to negative x quantity squared plus 1. So we know that this simplifies to x squared. So we just copy plus 1. So as you can see, even if there is a constant, the function remains the same. Therefore, our function is even. X squared plus 1 is even. So when we graph y is equal to x squared plus 1, it's just the same with the graph of y is equal to x squared. And because the only difference that they have is the plus 1, meron lang vertical shift na 1 unit. See, y is equal to x squared plus 1. So same lang din yung graph nila. Umangat lang si y is equal to x squared plus 1. So kahit umangat siya, symmetric pa rin siya about the y-axis. That's why y is equal to x squared plus 1 is even. Sir, what about odd functions? So don't be confused kasi baka iniisip nyo na if even, symmetric with respect to y, kapag odd, symmetric with respect to x. No. So odd functions are symmetric about the origin. And algebraically, to say that a function is odd, f of negative x must be equal to negative f of x. So here, we're doing another step, which is getting negative f of x. We have y is equal to x cubed, or f of x is equal to x cubed. Then, f of negative x is equal to negative x quantity cubed, or we can rewrite this as negative x times negative x times negative x. So negative times negative is positive, times negative we have negative x cubed. So that is our f of negative x. So now let's get negative f of x. So here we just multiply everything with negative 1. So we get the original function, which is x cubed multiplied to negative 1. So negative f of x is just equal to negative x cubed. Now, we compare f of negative x with negative f of x if they are equal. So f of negative x is equal to negative x cubed, and negative f of x is equal to x cubed as well. Therefore, the function y is equal to x cubed or f of x is equal to x cubed is an odd function. Sir, paano ulit pag may constant? So, let's use the same example. But this time, let's add plus 1. So, we have y is equal to x cubed plus 1 or f of x is equal to x cubed plus 1. So, let's find f of negative x again. So, f of negative x is equal to negative x quantity cubed plus 1. So here the 1 remains unchanged. So f of negative x is just equal to, so we already know this is negative x cubed plus 1. Now let's find negative f of x. So to do that, we multiply our original function f of x with negative 1. So our original function is x cubed plus 1 multiplied with negative 1. So that would give us negative x cubed minus 1. So that is our negative f of x. Now let's compare again f of negative x with negative f of x. So for f of negative x, we have negative x cubed plus 1. And for negative f of x, we have negative x cubed minus 1. Are these two equal? So they're not equal. Therefore, when we add a constant, the function is not odd anymore. So this is also not an even function since when we compare f of negative x with the original function f of x, they still are not equal. So sabi natin kapag odd function, symmetric about the origin, pero kapag ginap natin si x cubed plus 1, it's no longer symmetric about the origin. Symmetric na siya about the point p is equal to 0, 1. So therefore, hindi na talaga siya odd function. Sir, hirap naman. Daming kailangan gawin, daming kailangan tandaan. X squared plus 1 pa lang tsaka x cubed plus 1. Paano pag mas mahaba na yung function? So ito na guys, ituturo ko na yung shortcut. So we're not going to use these anymore. We're not gonna use f of negative x is equal to f of x for even functions and f of negative x is equal to negative f of x for odd functions. We just have to inspect the given. So if all the exponents of x are even, therefore the function is even. So it's okay if there's a constant or none because we can rewrite c as itself. So c times x raised to 0. And we all know that x raised to 0 is just equal to 1 because any number raised to 0 is 1. So therefore, this becomes c times 1 or just equal to c. So for even functions, we just have to check if the exponents are even. But for odd functions, we have to inspect all the exponents of x and make sure that they are odd, and also make sure that there are no constant terms in the given. So let's apply this newly discovered technique for some, and if you already know, then you can solve with us. So here are a few examples. So determine whether the given function is odd, even, or neither. So let's check the exponents. So here we have x cubed plus x squared plus x plus 1. So the exponents are 3, 2, 1, and x raised to 0. So therefore, not everything is odd, not everything is even. So this is neither even nor odd. For the next one, we have f of x is equal to 2x squared plus 6. So here we have x squared, and we have 6 times x raised to 0. So everything is even, therefore this function is even. So how long did that take? I'm sure it's under 5 seconds. So let's try the other one. 4x raised to the 5 plus 2x cubed. So 5 and 3. So therefore this is an odd function. So here, 8x raised to the 6th power minus 6x raised to the 4th plus 4x squared minus 2, or just 2 times x raised to 0. So everything is even. 6, 4, 2, 0. Therefore, this function is even. So negative 2x cubed. So the exponent of x is odd. And there is no constant. Therefore, this one is odd. So here we have x squared plus 2x plus 1. So 2, 1, and 0. So not everything is odd, not everything is even. This one is neither even nor odd. And lastly, we have 2x cubed plus 3x. So we have 3 and 1. So the exponents of x is 3 and 1. Therefore, this function is odd. So see, that's how easy it is to determine whether a function is odd, even, or neither, just by inspecting the exponents of x and checking if there is a constant or not. Yan lang pala kadali yun, sir. So if gets mo na, sabi nga ni Architect Lion Austria, isa ka ng big brain. So now let's apply what we have learned so far in integral calculus. So when integrating even functions over a symmetric interval from negative a to a, we can simplify the process and the formula becomes 2 times the integral of f of x dx from 0 to a. So this makes our calculations easier since anything multiplied to 0 is equal to 0. Therefore, many terms will be cancelled, making our computations faster. So for example, here we have evaluate the integral of x squared plus 2 from negative 2 to 2. So we have x squared, or x raised to 2, which is an even number. And we can rewrite our constant 2 as 2 times x raised to 0, because when we simplify this just becomes 1. So therefore, this one is even as well. And since all exponents of x is even, our function is even. Now that we know that the function is even, we can apply the formula for integrating even functions. So instead of evaluating from negative 2 to 2, we can just evaluate the integral from 0 to 2 and multiply the result by 2. So we have x squared plus 2 dx. So integrating this gives us 2 times x cubed. So 2 plus 1 is 3. Then from the top, make it drop. Plus 2x. So when we integrate any constant, we just attach the variable with which we are integrating. So in this case, we have dx, so we are integrating with respect to x. So the integral of 2 is just 2x. Evaluated from 0 to 2. So we have 2 times 2 cubed over 3 plus 2 times 2 minus 0 raised to 3 is 0. And 0 divided by any number is just 0. Plus 2 times 0 is just 0. So see, that makes our calculation much faster and much easier. So here we have 2 cubed is 8 divided by 3. So we have, let me just write here, we have 8 over 3 plus 4. Then multiply that by 2. So that gives us 2 times 8 over 3 plus 4 is equal to 8 over 3 plus 12 over 3. This becomes 2 times 20 over 3. And finally, multiplying 2, we get 40 over 3. So this is our final answer. So next one, for odd functions. This one is much easier. So when we integrate an odd function over a symmetric interval from negative a to a, so this can be any constant, the answer is simply 0. So here, let's evaluate x cubed dx from negative 3 to 3. So here we have x cubed. So by inspecting the exponents of x, we have x raised to 3. So this one is odd, and there is no constant. Therefore, our function is odd. And then let's check if we have a symmetric interval. So we have negative 3 to 3, or from negative a to a. Therefore, this one is just equal to 0. So that's how easy it is to integrate an odd function with a symmetric interval. So you just end up with 0. So now it's time for you to try it yourselves using these examples. So the first one is an odd function, and the interval is symmetric as well, from negative 69 to 69. Therefore, the result here is just 0.
Nice.
And for our last example, we have 5x raised to the 4th plus 3x squared integrated from negative 2 to 2. So here we have x raised to the 4th, which is an even number. And here we have x squared, or x raised to 2, which is an even number as well. Therefore, our function is even. And when we integrate this, we get 80. So hopefully guys, you got the correct answer in both of these examples, using as little time as possible because of the techniques that you were able to learn in this video. But if you are unlucky and solutions are required in your exams, at least you can be more sure of your answers. And if solutions are not required, then you can answer more difficult questions that take more time to solve. That's all for this video. If you learned something, please don't forget to hit the like and subscribe button and share it with your friends and classmates as well. It will help me produce more educational content and reach a wider audience. And as always, I'll see you on the next one. Peace!